So in these notes, we're going to determine if what we have is linear or not. And our essential question is, can I identify and represent patterns that describe linear functions? Kind of have a lot of random notes here that we need to take. And so with that being said, we want to review very quickly our coordinate graph. If we have a coordinate graph, as shown here, we know we have our x-axis goes left to right and our y-axis goes up and down. And remember, what I get written on my notes, I need for you to please get written on your notes. A couple points I want to identify. We have where the two lines cross, the x-axis and the y-axis, that is located at 0, 0, and that is called the origin. That is our origin. And so then when we have that point, we call it a coordinate point or an ordered pair, and we know that the first number represents our x, the second number represents our y. And our x again goes left to right, and our y goes up and down. So if I were to give you a point, let's just say -2, +1. That means to graph this, we would start, I'm going to put some numbers on my graph here. That means we would start at 0, 0, and we would go on the x backwards 2 spaces to the -2. -1 would be our first one, and -2. And we would go up 1 space and plot the point. So graphing, and that should be a review. Graphing should definitely be a review. Let's also talk about, sometimes there are different words that represent our x-axis and our y-axis, or our x variable and our y variable. And so we know the x here, this is going to be our horizontal value. Something else that we can use to represent or call the x would be our independent variable. Independent variable. We can also call the x the input. The input. It's got lots of names. And the x can also be called the domain. Those are all words that would describe our x value. Let's talk about our y value. Well, the opposite of that horizontal, it's going to be vertical. It's the dependent variable. Instead of the input, it represents our output. And instead of the domain, our y value is called the range. So those are words that would describe our x and our y. So a lot of this, I bet, is a review. Let's go ahead and move on to the next slide. And we also reviewed how we graph values that mean our x and our y. So there's a lot going on in this lesson, but that's it. Here, we're going to start talking about what linear means. Okay? And if we know that something is linear, it's going to have a constant rate of change. Let's talk about what that graph would look like. And what I want you to look at is the first four letters of the word linear, and it spells what? Line. And so linear, the graph is going to be a straight line. So if we have a straight line, we have a linear equation. If we have a table, if we look at a table and we want to determine if it's linear or not, we're going to look at what we call a constant rate of change. We're going to make sure that the x and y change at a constant rate. And when we look at that change, we are looking for addition or subtraction. So they're changing at a constant rate by either addition or subtraction. And then when we look at the equation, okay, well, we're going to have an x and a y. So we're going to have like y equals, and we're going to have an x value. And we're going to need to have that constant rate of change here. So whatever that rate is that it's changing by, it's going to be a number value. Okay? And the biggest thing I think we need to think about when we look at linear equations is that we have no exponents. I'll write this down here. No exponents. Okay? We're going to have the power of 1. And our next lesson will be on nonlinear, and we can talk more about what those look like. But linear is going to be y equals with your rate and then times that x. So I've given an example here, and I kind of already started to write all over my example. And I am actually going to go ahead and erase this just because I need the room. So you keep it written on your paper, but I do need the room. I apologize. So as we go ahead and look at this example, we have a table. Okay? We have a table, and we want to determine if this table is linear or not. So let's see if it goes by a constant rate. Let's check out the x's. I go from 1 to 2, that would be a plus 1. 2 to 3, plus 1. 3 to 4, plus 1. So my x's are all changing by a constant rate. So far, yes, it is linear. Let's look at the y's. Plus 2. Plus 2. And plus 2. So my y's are all changing by a constant rate. Adding by 2. So yes, this is linear by just looking at my table. Yes, it is linear. Okay, we know it's going to go up. It's going to be a straight line on my graph. So let's graph it. We're going to go over 1 up 14. We're going to go over 2 up to 16. Over 3 up to 18. Over 4 up to 20. So we can see, if we were to connect it, that those are in a straight line. Hard to tell when you're not using graph paper. But what I also want to make sure that we can do, and this is kind of the hard part, is we want to get our equation. And so our equation, remember, is that y equals, and we have to find our constant, x. And then we have to talk about our beginning value because we're going to add on that beginning value. So let's first talk about the constant. And the constant we're going to get out of the table. Your constant is going to be y over x. So talk to me about what is my y over my x here. Well, it's 2 over 1. The y's are all changing by 2. The x's are all changing by 1. There is our constant. That's our rate of change. We're changing by 2 every 1. So every time x increases by 1, y increases by 2. And now let's talk about that beginning value. That beginning value. And there's a couple things to look at here. The first thing we could look at is if I were to take my ordered pair, 114, if I put 1 in for x, how am I going to get 14 over here? 1 times 2 is 2, plus what gets you 14? Well, it's 12. Let's check the next one. Let's check the next one and see. I'm going to erase this. Let's check our next ordered pair. My other ordered pair was 216. If I put 2 in for x, and 16 is our y value, is 2 times 2 is 4. Is 4 plus 12 16? Yes. So that beginning value there is 12. We'll talk more in depth about how we actually find that beginning value. Okay. So your equation for this one would be just y equals 2x plus 12. That is the equation that goes with the graph, that goes with the table. So now let's go ahead and we're going to look at our very last slide. We talked about what linear means, and we looked at an example of where we have a table and we made the graph and we wrote the equation from it. And here we're talking about what a function is. And we're going to come back to functions later on. So this is not the only time we're going to talk about this. And the definition is every x has exactly one y value. Every x has exactly one y value. And the question that I would tell you to ask yourself every single time, we're going to type this in, I'm going to type it in, you're going to write it down. The question you need to ask yourselves are all the x values different? Are all the x values different? If the answer to that is yes, then yes, it is a function. If the answer to that is no, then no, it is not a function. That is the question you want to ask yourselves. So let's go ahead and look at this first one. Let's look at our x values. I have a 2, a 4, and a 6. Are all your x values different? Yes. So yes, a function. That means every x has exactly one y value. We're looking at the x's. Let's go ahead. That's from a table. And when we look at ordered pairs in example 2 here, we need to remember which one is the x and which one's the y. Remember, we're looking at our x's. It's the first one. Okay, remember it's xy, 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 and xy. So we want to look at all the blue x's. We're going to ask ourselves the question, are all the x values different? I'll read them to you. -1, 0, -2, -1. I repeated my -1. So the answer would be no. They're not all different. So no, not a function. So that's kind of an intro into functions. That's summarized. I know there's a lot of different things we talked about. We talked about functions.